Hello and welcome to another video. To solve this equation, the first thing I'm going to do is to write 4 in terms of base 2 and then carry the power of 4. I'll bring it here so that it becomes a multiplier of the log. Okay, so now after that, I'm going to apply one of the properties of logarithms known as change of base. So I'm going to write this again: log to base 2 of x plus log to base x of 2 raised to the power of 2 then equals to 3. So I'm going to bring the power, I'm going to bring it here so that it becomes the multiplier of the log. So that I'll write this again: log to base 2 of x plus 2 log to base x of 2 is equals to 3. So to make the base of log to base x of 2, to have this, as in to make this have the same base as this other log here, okay, I'm going to apply one of the properties of logarithms known as change of base. So using the logarithmic property, log to base a of b, okay, equals to 1 over log to base b of a. So which means log to base x of 2 will be equals to 1 over log to base 2 of x. So that this, from here, we then write, so we have log to base 2 of x plus 2 multiplied by 1 over log to base 2 of x equals to 3. Now, let me represent log to base 2 of x with a letter. That is, I'm going to substitute a letter, okay, for log to base 2 of x. That is, if I let k to be equals to log to base 2 of x, so which means this equation will now be k plus 2 over k equals to 3. So now I'm going to multiply through this equation by k. So multiplying through this equation by k, this will be k times k. This will be k squared. Then k multiplied by 2 over k. This will be 2. K times 3, or 3 times k, that will be 3k. Then I'll carry this over to the left hand side so that we can have k squared minus 3k plus 2 equals to 0. Now we have a quadratic equation. So to solve this quadratic equation, I'm going to use method of factorization by splitting the middle term, and that will be k squared negative 2k minus 1k plus 2 equals to 0. Then to write my factors, now k squared divided by k, that will be k. I'll divide this by k, then minus 2k divided by k, that will be minus 2. Okay, then negative 1 into k minus 2 equals to 0. So that k minus 1 multiplied by k minus 2 will be equals to 0. Then I'm going to set each of these equals to 0. That is k minus 1 equals to 0. Then k minus 2 equals to 0. So that k will be equals to 1 or k equals to 2. Alright, so now we have two values of k. So which means we are going to use these two values of k to find two values of x that satisfies this logarithmic equation. So which means first I'm going to recall that k is equals to log to base 2 of x. So case 1, when k is equals to 1, so which means we're going to have 1 equals to log to base 2 of x, okay, so that x will be equals to 2 raised to the power of 1. Then the value of x will be what? 2. So the value of one of the values of x is 2. Now case number 2, case 2, okay, now when k is equals to 2, so which means 2 will be equals to log to base 2 of x, which implies that the value of x will be equals to 2 raised to the power of 2, and that will be 4. So which means the value of x is 4 when k is equals to 2. So therefore, x equals to 2, okay, that is x1. Let me write x1 equals to 2, and x2 is equals to 4. So these are the two values of x, okay, which satisfies this equation. Okay, let's verify our answer. Let's verify. Now we are given log to base 2 of x plus log to base x of 4. Now will it be equals to 3 when the value of x is 2? So that's x1. So at x equals to 2, okay, if we plug in the value of x, which is 2, into this equation, are we going to get 3, which is on the right hand side? Now I substitute. So this will be log to base 2 of 2 plus log to base 2 of 4. This is 1. When the argument and the base are the same, then we have 1 as the answer. All right, so in this case, this will be plus log to base 2 of 2 raised to the power of 2. So I'm going to take this here, okay, so that this will be 1 plus 2 log to base 2 of 2, which is what? 2. So that this will be 1 plus 2, and that equals to 3. Verified. Okay, now when the value of x is equals to 4, when the value of x is equals to 4, when the value of x is equals to 4, so we are using the same equation to verify. So I have log to base 2 of 4 plus log to base 4 of 4. Now will this be equals to 3? So in this case, this will be log to base 2 of 2 raised to the power of 2 plus 1. Argument and the base are the same, so that will be 1. Okay, now I'm going to take this guy here to become the multiplier, so that 2 log to base 2 of 2 plus 1 will be equals to 2 plus 1, and that will be equals to 3. Verified. So which means x equals to 2 and x equals to 4. That is 2 and 4, which are the two values of x. Those are the two values of x that will satisfy the logarithmic equation. No blessed pleasure. It's the joy of understanding. Bye-bye.